Good morning and welcome, everybody. Today is our product engineering day. I hope that your students are ready and have some amazing ideas in their head that they're going to be able to make in real life with prototypes on our 3D printers. And don't worry if you don't have a 3D printer. Engineering Tomorrow will print your students' prints for you. You're going to send us your STL file. You're going to get all that information today. But I am going to stop speaking because now we need to start our introduction. And we have an amazing presenter here today. Mr. Alston Clark is going to be our master of ceremonies today, who's going to be with us all day. So, Alston, if you want to take it away and start our introduction for our product engineering event.
Thank you so much, Monica. Hello, everybody. I'm going to share my screen and we're going to get right into it. All right. Okay, here we are.
Oh,
Let's do it again.
I was going to say I see them, but then they disappeared. While Alston is getting that all set, just a reminder, please remain on mute while Alston is presenting. And please rename yourself. And if you need assistance, we can assist with that. All right,
Oh,
Alston, you're up.
cool, cool. Can everybody see my screen?
Yes.
Yes.
Excellent. Okay,
Alston, just quickly,
great.
I'm sorry, we're
Yeah,
seeing your screen with your presenter notes. I think you want to show our slideshow screen.
yeah, I do. Give me a second here.
Welcome to Zoom World, everybody. We always deal with our fun in Zoom Live, so I know that all the teachers are familiar with it. So just bear with us quickly while Alston shares the correct screen, and we'll be rolling shortly. I see more students are popping in, and teachers, we're excited to have you all here. Hope you guys are all ready for a fun day.
How's that?
Now it's good, Alston.
All right, let's go, everybody. So product engineering, this is an extremely exciting lab. And let me tell you a little bit about myself. So my name is Alston Clark, and I am an engineering mentor here at Engineering Tomorrow. And my general interests are centered around technology consulting, data engineering, and artificial intelligence. So I grew up in DC, and I went to Howard University and I studied computer science. Some of the places that I've worked at while in college and out of college are Google, Apple, and Capital One. And I want to tell you a little bit about how I got my start in engineering. So I was always interested in how things work, right? I was always the person that was interested in putting things together and taking them apart. So that journey led me to study engineering. And you can see me here with this big robot. I was on a robotics league in high school. I'm a very competitive person, so I love anything that has competition. So I would do competitions that are called hackathons, and that's when you join a group of people together for 24 hours and you build an application and then you present it at the end. So that's me in college right there in the middle. That's probably at like 4 a.m. in the morning or something. And then the two pictures on the right are me at work, and I still am able to keep that competitive energy going even at work. Now, if you don't remember anything that I say for the rest of my presentation, I want you to remember this. It only takes two things to make it in the engineering world, and those two things are curiosity and dedication. The reason being is that curiosity is what makes you ask why, and dedication is what makes you stick around to find out. So I want to share a little bit about this is our breakout development team. Like the information that you're going to be reading today and learning about has been developed by amazing engineers here listed on your screen. And just know that you're in good hands and that you're going to take away things that are going to help you in the engineering world to come. Now, what we need to know is we got to start at the high level. All right. Sometimes engineering may seem kind of like complicated, it may seem a little tricky, but I want everybody to understand that if something is confusing you, zoom out, zoom all the way out and ask why. Remember what I said, y'all, you got to be curious and got to ask why. So when it comes to product development, right, we have these different stages here. If you look all the way to the left, you have the product manager, right? So that's like define and refine the idea, okay? Then you have the research and design stage, okay? And this is where we're going to get designs that are going to ultimately become what we are looking to build, right? And then somebody has to go out and purchase those materials, right? These materials aren't just, happening to be inside the laboratory. Somebody's responsible for ordering each and every one of them. Okay. And then we have the manufacturing engineer. And that's the hat that we're going to put on today, right? We're going to be the manufacturing engineer. So the materials have already been purchased, right? Designs have been made. The product manager has given us a general layout of what we are to create. And now we have to go out and curate it. This lab is going to show you tools and technologies that are going to do just that. And that is what manufacturing engineering generally is all about. So intro to manufacturing engineering. Now, I will also share that this is something that everybody is familiar with, whether you know it or not. And I'm going to tell you why. So what does a manufacturing engineer do, right? Well, manufacturing engineers design and operate the manufacturing system for a product, all right? If you've ever seen a machine shop or a production line, assembly line for maybe your favorite toy, your favorite video game, or object that is around your house, that was created by a manufacturing engineer. All right, so they design also the factories that will produce and manage the maintenance of the products that you love and that we use in our everyday life. All right, so I'm gonna take a moment real quick and I'm gonna pause and I want everybody to think about household objects that they use every single day. All right. So I know I use the remote control to change the channel. Okay. I like using my toaster oven to heat up my breakfast. Okay. These are all things that are made by manufacturing engineers. All right. Let's keep it going. Now, I love to show visuals because it helps bring everything home. So I'm going to show you all a quick video of the day in the life of a manufacturing engineer. All right, let's take a look.
My name's Jonell, and I'm a manufacturing engineer at Space Systems L'Oreal in Palo Alto, California. Space Systems L'Oreal makes commercial satellites for all different kinds of companies. They do things like TV, radio, some weather satellites. My work is involved in making sure that we get everything done on time. A big part of that is making sure the technicians have what they need. You can see some of the thrusters up there. The thrusters aren't fueled up yet. I went to junior college and I was just taking classes. My advisor asked me what I like to do. And I told him I liked, some science stuff and gave him like general background. And he told me I should be an engineer. And eventually I transferred to San Diego State and then I got a degree in engineering. A typical day for me is like I come in, I go into what we call our laboratory, and I walk around, I'll talk to the technicians, kind of make sure that they have everything they need as far as being able to understand drawings, having all the parts, having everything from chemicals that they need to do different processes. We do a lot of calculations on our efficiency and whether or not we're making things at the correct speed. And we have what's called a design engineer, and they basically design a lot of the satellite and different parts of it. And sometimes their drawings aren't totally clear. My job, if the technician says, "Hey, I don't understand this drawing," then I have to kind of interpret it or figure it out or call the designer and see if he can explain it to me. And then after I understand it, I'll go and try and put it in layman's terms to the technician. I maybe don't apply like everything that I learned in calculus and algebra, but I do apply like not giving up on a problem or sticking with it, or just because something's difficult, I don't give up. The classes that would have helped me in high school probably were obviously the math classes, even though I was bad at it. English classes, because you do a lot of writing. You do a lot of just writing emails and stuff, and you don't want to sound dumb when you have to write to your manager or somebody else's manager. I like interacting with people and helping people. And if I was like recommending anything to a high school student today, I would say take as many classes as possible and as many different things so you get a taste of everything and you can find out what you really like.
All right. One of the things I want to emphasize that he mentioned is that get a taste of everything and figure out what you really like. Now, I want to show you something real quick. This is something that I 3D printed myself. All right. So I'm going to hold these up. You see this? This is a pendant for a necklace. And this is a ring. All right. I'll put it in my, it's the plastic that we printed it with is clear plastic. So it's a little bit difficult to see, but I'm going to show you what it looks like when it was created, when the mold was filled with silver. Here you go. So this was a fun project I did. I wanted to design some jewelry, and the way we did it was we used computer-aided design, and we created the size and the image that we wanted, and then from there we had the mold and we filled it with sterling silver, and that was a bulk of the jewelry making process. So that's the cool thing about engineering and manufacturing. You may have a specific interest on like something that you want to build, and this is a pathway for you to, exercise that desire. So what are some different types of manufacturing? All right. This is something I really want everybody to take home. And I have a question on the next slide that I'm going to be looking for your input on, okay? So on the left, top left, we have additive, right? And that's when we start with nothing and we build up a design, okay? We have subtractive, where you remove material to create a design, right? An example of this would be, I'm not sure if you've ever seen a carving of wood, right? Like a table. It started with the big, you know what the shape of a tree is, right? A big tree trunk, and then ultimately they carve it down until they get the pieces that they want to make the table. That's subtractive. You have forming, right? Applying a force to create a shape. This is a horseshoe right here, all right? They're heating it up and they're bending it into the shape that they want it to be. And then we have casting, right? Liquefying material and put it inside of a mold. So that's what I was doing with the silver design here. Created a cast, and then it was filled with silver, and then it was pulled down. So these are the different types of manufacturing, all right? Remember these. Now, what type of manufacturing do you think is 3D printing? And for the students that have a computer in front of them, I'd like you all to type in the chat what your answer is. Okay, I see a student from South Dade High School says that it's additive. Okay, I see Bladensburg High School says that it's additive. Archimedes High School in New York, additive. Okay. Thank you all for that feedback, all right? Yes, indeed, it is additive. And I'm sure many of you have 3D printers probably inside of your classrooms, right? So you see how it's done, you see how you're starting with nothing and ultimately layer by layer, that 3D printer is creating the product right there in front of your eyes. So great job, y'all. Part 2, intro to 3D printing. All right, 3D printing is one of the applications of a manufacturing engineer. Now, when it comes to 3D printing, I want to show y'all this video because he's going to give you guys a quick overview.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be.
Wow, how about that? That's amazing. A 3D printed house? That's cool.
3D printing technology.
Question for everybody, and again, we can type in the chat if you have a computer in front of you. I'd like to know, what is something that you would like to 3D print? Or even something that you've already 3D printed in the past. You can go ahead and type it in the chat. And I know lunch is coming up, so maybe some of you would like to say a 3D printed pizza. And, you know, if that's the case, save me a slice. All right, I see Archimedes High School. Yes, we're 3D printing food. I'm gonna give that a thumbs up as well. 3D printed dinosaur. That would be amazing. Yeah, he said that the 3D printed houses cost less than $5,000. So that may be something that we see more of. I'd like to see how big that 3D printer is because I know it'll be huge. Okay, prosthetics, absolutely. That is an application that we'll learn a little bit more about today in this lab. 3D printed car, that would be super cool. Yeah, absolutely. That's the beautiful thing. 3D printing, the sky's the limit. A lightsaber, oh yeah. I wonder what material it will be used to make the light part of the lightsaber, the laser part. 3D printing, okay. 3D printer, yep. 3D printer parts, that's real. Like making the needle, the tip. Okay, these are some great ideas. Let's talk about some of the benefits of 3D printing, all right? Now, 3D printing, some of the highlights of 3D printing are when it comes to rapid prototyping, all right? And when it comes to manufacturing, we're going to talk about constraints. One of the constraints is time. So when the product engineer comes to you with a product to build, there's always a time that is associated with it. So unfortunately, we don't have, you know, as much time as we want. And that's why sometimes 3D printing is something that can help us get something quickly. And even if we are not going to use what we 3D printed in the final design, it can help us lead us in the right direction. So rapid prototyping, safe, no welding, no sawing. And generally speaking, it's a lot less wasted material, given that you only print what you need. And as we'll learn a little bit more with our computer-aided design, right, we can produce highly accurate and complex custom designs. Okay. So having that customizable aspect to it is is huge, especially in the engineering world where things have to be precise. All right. And again, it's lower cost, given certain materials that you may use for testing. Say, like, for example, you're building something that ultimately is going to be made in gold or silver or even metal, right? And you think about the technology that will be used to put that together and test with it. It may be easier just to make a model in plastic and see if you're moving in the right direction. And then from there, get feedback. And then once you've locked in on the design that you know you're going to build, then you move on to using the material that is going to be in the final product. All right. So those are some of the benefits of 3D printing. So if anybody ever asks you, oh, why 3D printing? You know, what's the purpose of it? You can let them know, hey, it's lower cost. Generally, it's quicker and it's extremely customizable. All right. Now, drawings and dimensions. This is, when it comes to 3D printing, this is I might say, either the number one or the number two most important thing. Drawings and dimensions. Now, I have the acronym right here on the screen, CAD, all right? With CAD comes another step, and that is drawing. And I just got a quick question. You can answer it in the chat. Who knows what CAD stands for? Type it into the chat. Spell it out. I see that Duval High School just finished building cell phone holders. That's amazing. Way to go. I went to college with a handful of students from Duval High School, and let me just tell you this, they are amazing engineers right now. So shout out to Duval High School. And I actually visited your school last year. Okay, South Dade High School says computer-aided design. Ding, 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 we have a winner. All right. This is computer-aided design. And why do we need computers to aid our design? Well, it's going to help us encapsulate very specific aspects of the design that may be hard to articulate verbally or even in pen. Right? So it's important when you send your designs to a manufacturer that you specify everything. I'm talking about the shape, the size, the materials, the sequence of assembly, right? And in this case, we have to show the different sides of what it is that we're going to build, right? So as you can see here, we have an industrial part, and we have pictures of it from every different angle, top, front, side, and isometric, okay? That isometric is synonymous with the 3D aspect of it, all right? So you can kind of see what it looks like in space. Now, all of these parts are necessary when you're building something, right? You can't just say, you're a manufacturing engineer and somebody comes up to you and says, hey, I want you to build me a car. And you say, wait, what type of car do you want me to build? And they say, a fast one. I'm sorry, that's just not enough information, because I may come back with a Mustang, right, type of a vehicle, but you're a Camaro person. So you're going to say, this isn't what I wanted. Well, my response will be, you didn't specify. And this is how you specify. This is another one of the key things I want everybody to really, really make sure that you take home with you. We have to have every single angle, right? Every single view of what it is that we're designing. So here's a quick activity, right? I mentioned to you some of the different angles that we have to have designs for. And I'll say those again: top, front, side, and isometric. All right, remember that. When you're designing something, like I'm sure the students at Duval High School, they had to draw the design from the top, front, and the isometric perspective, right? And we have something right here in front of us. We're going to do this together, all right? And you can put this in the chat again. Right here in the middle, we have a shape, all right? And we have these three ones that we want to fill in: top, front, and side. So from the images that we have here right in the middle of the screen, 1, 2, and 3, I want to know which one is the top, which one is the front, and which one is the side. I've given you all a head start because I've already told you this is what the isometric view of this structure is. And now I'd like you all to put in the chat. You can just say top is 1, front 2, side 3, etc. And let's see. Yes, indeed. Challenge Prep Academy. I see you all. Computer aided design. All right. Bladensburg High School says number 1 is top. Okay. 1 is the front, 2 is top, and 3 is side. Okay. South Dade High School, we see top is 2, side is 3, and front is 1. Okay. Dr. Jackson, top is 2. Okay. Side is 3. Okay. All right. All right. All right. Let's take a look, everybody. Top is 1. Okay. Excuse me. Top is 2. Yes, y'all know that. The front is 1 and the side is 3. Great job, everybody. How did everybody know that the top is 2? Well, if you look at the isometric view, we can see that we have these 2 dots or circles. we're not 100% sure what it is. That's okay. And then we see here number 2, we can see that those 2 circles are represented. That's going to let us know that it's the top. All right. And so on and so forth. Excellent job, everybody. Let's keep it moving. So again, this is something that I really want you all to take away, right? If somebody asks you after today, what did you learn today in the Engineering Tomorrow presentation, you can let them know, well, I learned the importance of having multiple views when it comes to a computer-aided design for the purpose of 3D printing, right? For example, we have this beautiful masterpiece in front of us. Look how beautiful this is, y'all. Like, this should be in an art gallery. Like, this is really speaking to me. It's actually making me a little bit emotional. And I got a question. What is this? And I'd like to take a few guesses in the chat. What do we have right here in front of us? Who can guess what this is? Any ideas? What could this be? Well, okay. From Duval, okay. A box. There we go. A bookcase, okay. A cylinder. What could it be? It's mysterious. Modern art. I love that answer, Dr. Jackson. Yes, indeed. Well, the reality is, according to this, we have right here a tissue box. And this is the importance of multiple views, because it's impossible to know 100% what this is until you see the top, the side, and the isometric view. All right, so now you all know what the importance of having multiple views is, because if you don't have them, nobody's going to know what you're trying to build. Okay, this is a tissue box. All right. So this is the importance of dimensioning. Just like having multiple views gives a better understanding of what needs to be built, so does dimensioning. All right. Let's look at this engineering drawing. And I also want to ask you all, what do we have here? If you take a look at it, we have different images of this product. Now, dimensions get into how big is something, right? So when you draw it to scale, really your imagination could tell you that, hey, this is a bridge, right? It looks like a bridge. Could also be a step stool, right? To reach something on the top shelf or the top, in the top cabinet of your house. Or it could just be a toy block, right? But it just depends on how big the structure is that you had in front of you. And that's why we have these numbers right here. All right. So that's why we have our dimensions. All right. So as we get into our activity later today, I just want to make sure that we're all clear. We're going to have our top, our front, our side, our isometric, and the dimensions of these structures. All right. That's what a complete computer-aided design looks like. Now that's the minimum. All right. So that's how we know we're moving in the right direction. All right. So we're kind of coming to an end here, right? We're about to get into the building aspect of it, which I know y'all are excited to do. And part 3 is getting started with your 3D printing product development challenge. Now, everybody has a student interactive workbook. All right. You have your teachers there with you, and they're going to help walk you through this process. I'm just going to give you a quick overview. All right. Inside of this lab is going to give you the skills to begin or continue your 3D printing journey. And we're going to be using a computer-aided design technology called Tinkercad. Okay. Tinkercad it's going to help you take your ideas from idea stage into something physical that you can touch, that you can show, and that you can solve real world problems with. All right, so you're going to make your account, you're going to create a design, right? And you're going to select, modify, size, orient, place, and group objects. And this is going to be fun. This is something that has to be done. Everybody has to know how to do this in order to make more complex projects. So your task today, rapid prototyping, all right? So you're going to familiarize yourself with Tinkercad. You're going to identify a problem within your home that you would like to design a solution for. Now, I know the students at Duval, they created a phone case, right? Or a phone holder. And that's a solution that they found that was important. So I'd like to know, what solutions would you all like to create today? Okay. It's always good to solve a problem. Make something that's useful, or maybe make a piece of art, because art is useful as well too. I'm an artist. We're going to follow the engineering design process. Okay. Things to confirm: when you're finished, your piece is going to be flat against the work plane. All of the shapes in your piece are connected using the group option, and your piece is within the size constraints. Refer to the student interactive workbook if you have any questions, and also your teachers will be able to help you as well. All right. Here's the constraints, everybody. Now I mentioned that time, right, is a constraint, and now we have a size constraint. The maximum dimensions of your object are going to be 10 centimeters by 10 centimeters, and the height should not exceed 2 centimeters. All right. This is the engineering design process, and I want to take a big zoom out. I want to zoom out real quick. Okay. When it comes to creating something, we have to think about it in these like steps. So you have the learn, design, build, test, deploy, and it kind of keeps on going around. So you're a design engineer. How would you use the engineering design process to create a product that will solve the problem that you've identified? All right. And in this case, the client, it may be you. So you're building something that's going to help you, or it may be somebody else. For example, there was a student that mentioned using 3D printing to create prosthetics, right? So in that case, you could speak to somebody who is in need of a prosthetic, and they would be the client, right? And one of the things that you see in this circle right here is that each and every one of the steps, from design to test to learn, it's all associated with getting confirmation from the client. You have to make sure that what you're building is actually what the client needs. And the only way to do that is to keep the lines of communication open and confirm your hypothesis, all right, again and again. And as you keep going through that process, the product gets better and better. All right. Yes. All right. So why do we have constraints? Right? Constraints or limitations on design. Are constraints a bad thing? Are constraints a bad thing? Let me know in the chat, y'all. What do y'all think? Would you say that constraints are a bad thing? South Dade High School, I see y'all. Salute. Challenge Prep Academy, I see y'all. Salute. All right. I see from Duval that constraints are a good thing. Archimedes High School says that they are necessary. Betsy Foreman says, I love constraints. It tells me what I need to create and the level of detail. I love that answer. Constraints, y'all, they're important. Without constraints, we wouldn't know how far to go. And we wouldn't know how long to stay. All right. So the level of detail would be an unknown. So we could just keep going and going and going and making maybe more detail than is needed. These are the three constraints that people generally think about: time, cost, and quality. Time, how long is it going to take? Right? How much time do we have to build? Cost, how much money do we have to purchase said materials? Quality, you could think about it as there are certain things where you can kind of skimp on the quality, not necessarily in a bad way, but it just may be like you don't need to have the top of the line material for this specific aspect of it. But there are certain things that you can't skimp on quality. If you see this picture right here in the middle, that's called a life straw, and it's used to filter out clean water. You can't skip on quality with that because it's something that you're putting into your body. All right, let's keep it going. We are going to actually begin to wrap up here. All right. I hope that you all have enjoyed this intro, and I'm going to stop my share. Hope you all have learned a few things, and I look forward to hearing soon how your build goes.
Well, I want to say round of applause to Alston
There we
Clark.
go,
We're going
hop
to
in
salute
there.
Alston because it is time for us to get into our breakout rooms. We have ET staff engineers along with two amazing college mentors. We have Bryce Camprett from Mississippi, University of Mississippi, and we have Dylan from Notre Dame University. They are going to be in the breakout rooms to assist you live time. So teachers, hop into that breakout room. It is open now. If you need assistance to get into the breakout room, just let us know.